In this video, I've compiled a few topics that have not come up on the Further Maths Paper 1, and I will be going through them because I believe there is a very high chance that they could come up tomorrow on your exam. So let's just get started. The first topic that we will be talking about is domains and range. The domain of a function refers to all of the x values that can be entered into the function and give out a y value. The range refers to all of the y values that can be outputted when entered into a function. So for example, if we have f of x equals 1 over x, you can't have x equals 0 because that would be undefined. So therefore, the domain would be x is not equal to 0. Likewise, the range would be f of x is not equal to 0 because y cannot be 0 either. Let's have a look at a few questions that could come up tomorrow. So you could be given the function and its range, and you could be asked to work out its domain. So what you'd do for that is you'd plug in the range that you're given into f of x, and then you work out the value of x for each of them. So say 3x minus 2 equals 34. So 3x equals 36. X equals 36 divided by 3 equals 12. And then you do the same for the 46. So it would be 3x minus 2 equals 46. 3x equals 48. And x equals 16. And then you write that out as an inequality in terms of x. You've got to remember that it's in terms of x and the range is in terms of the function. So it would be x is greater than or equal to 12, but x is less than or equal to 16. And that would be your answer. You could also be given the domain here and given the function and asked to work out the range. So you'd, in this case, you'd plug in x here and you'd work out g of x. So it would be 6 times by 8 squared minus 3 equals, and you put that into your calculator because tomorrow is a calculator paper, so you'll be able to use your calculators for this, and that would be 381, and then 6 lots of 12 squared minus 3 would give you 861. And then you do the same in terms of g of x, so you put g of x, say 381 and 861, and that's your answer. You could also be given a question like this where you have to sketch a graph. You'd be told what f of x is for different intervals and asked to sketch the graph. So here, told that f of x is equal to 6 from 0 to 3. So that would be from here to here. And then we're told that it's x plus 3, which means that for every 1 we go up, it goes 1 across. And it goes until 4, so that's only one box really. Like that. And then it's minus 2x plus 15. So for every box we go across, we go 2 down. So that would be here, here, and here. And it's until 7, so it's until here. And that's your answer. And then here we can be asked to work out what the domain or range is, and we would be given the function. So for here it would be g of x equals x for the first part, and that is from 0 to 3. So draw out 0 less than or equal to x, which is less than 3. And then it's also equal to just 3, the range of 3 to 5. So 3 less than or equal to x, so 5, and then 2x, because it's going 2 up, 1 across, so 2x, and then we can plug in a point here, so y equals 2x plus c, y here is 0, and y is 3, 2 times 5 plus c, so c is 3 minus 8, 3 minus 8 is 3 minus 10, which is minus 7, so it's 2x minus 7 between 5 and 6, so 5 less than or equal to x, which is less than 6. So that's your domain and range, and this is very highly likely to come up tomorrow. The next topic is increasing and decreasing functions. Now, when you think about increasing and decreasing functions, you got to think about the gradient, so you have to think about dy by dx. When a graph is increasing, dy by dx is going to be greater than 0. When it's decreasing, dy by dx is going to be less than 0. So, for example, this function here, the first thing we'd have to do to work out whether it's increasing or decreasing at certain points in the graph, we'd have to work out dy by dx, so it would be 4x plus 4, and we'd have to set that greater than 0 and then less than 0. This is increasing and this is decreasing. So 4x is greater than minus 4 and x is greater than minus 1. 4x is less than minus 4 and x is less than minus 1. So this graph is increasing when x is greater than minus 1 and it's decreasing when x is less than minus 1. Right, this one we'd still differentiate it, so 3 over 3 we get just x squared plus 3x minus 10, x squared plus 3x minus 10, I don't know what that 0 is doing over there, x squared plus 3x minus 10, and then actually yeah, we take equal to 0 and we factorize that, so it would be x plus 5 x minus 2 equals 0, so x equals 2 and x equals minus 5. Now we draw a sketch of the graph here. We've got quadratic graph in terms of dy by dx, which goes through minus 10 here, goes through 2 here, and minus 5. When x equals minus 5, if we want to know when it's less than 0 and when it's greater than 0. So it's greater than 0 when x is greater than minus 5, or no, when x is less than minus 5 or when x is greater than 2. And it's less than 0 when x is greater than -5, or x is less than 2. And these are our final answers for this question. The next topic is the nature of a point. So the nature of a turning point, or a stationary point, is the nature of a point where the graph dy by dx is equal to 0, so its gradient is equal to 0. Now there's 3 stationary points. There's maximum, minimum, and inflection. At a maximum point, d squared y by dx squared is d squared y by dx squared is less than 0, and when we have a minimum point, d squared y by dx squared is greater than 0, while at a point of inflection, d squared y by dx squared is equal to 0. So if we have a graph like this one, we'd first start off by differentiating it if we want to find the stationary points. So dy by dx is 3x squared minus 18x plus 24. If you want to find the stationary points, we know that dy by dx is equal to 0, so we'd have to solve that equation. We can divide this all by 3 because they're all multiples of 3 to make this a little easier, so it would be x squared minus 6x plus 8 is equal to 0. This can be factorized into x minus 2, x minus 4 equals 0. So we've got stationary points when x is equal to 2 and when x is equal to 4. We can find the coordinates of these stationary points by putting them back into our original equation. So 2 cubed minus 9 times 2 squared plus 24 times 2 plus 4. Just put that into our calculator because it's a calculator paper tomorrow. Which gives us 24, and then 4 cubed minus 9 times 4 squared plus 24 times 4 plus 4, which gives us 20. So therefore our stationary points are 4, 20, and 2, 24. We can then work out the nature by calculating the second derivative. So d squared y by dx squared is going to be equal to 6x minus 18. 6x minus 18 at 4 is going to be 24 minus 18, which is 6 greater than 0. So 420 is a minimum whereas 6 times 2 minus 18 is 12 minus 18, so it's minus 6, which means that it is a maximum. This is a maximum. Right, that is the nature of a point. The next topic is trig identities. Now there are two trig identities that you should really be concerned with, and that is sine of x over cos of x is equal to tan of x, and sine squared x plus cos squared x is always equal to 1. Right, let's have a look at some questions that they might ask you tomorrow. So prove that sine of theta times by cos of theta times by tan of theta is always equal to sine squared theta. So this part here, we know that we can rearrange this to get that. So sine of theta over cos of theta equals tan theta. So sine theta equals cos theta tan theta, and therefore this is the same as sine theta times sine theta, which is equal to sine squared theta. Alright, let's have a look at a tougher example. This was actually a question on a paper that appeared not too long ago, and it says show that this can be written in the form sine to the power of k x, where k is an integer. So the first thing we're going to do is we're going to factorize this bit here. So it'll be sine cubed x plus cos x 1 minus cos squared x all over sine x plus cos x. Now this part here, 1 minus cos squared x, is just the rearranged form of this. So we can just make a side note here that 1 minus cos squared x is equal to sine squared x. And so this is actually equal to sine cubed x plus cos x sine squared x all over sine x plus cos x, and then we can factorize again sine squared x, leaving us with sine x cos x, sorry, sine x plus cos x which is the same as the denominator, so we can cancel these out and we're left with sine squared x, and therefore k is equal to 2 because it's sine squared x. The final topic that we're going to look at is the equation of a circle. Now the equation of a circle comes in the form of x minus a plus y minus b equals r squared, where minus b is the where b is the y coordinate of the center of the circle, and a is the x coordinate of the center of the circle, and r is the radius of the circle. So if you have a look at this circle on the right, The equation of this circle would be x minus 3 squared, plus y minus 4 squared is equal to 5 squared, or x minus 3 squared plus y minus 4 squared equals 25. You could also be given the equation of the circle and asked what its centre would be. So in this case, the centre would simply be 5, 8. So you take this number here is the x, this number here is the y, but you have to flip the sign. And then the radius, just as a bonus, is the square root of 49, which would be 7. Alright, these are all the topics that I think are likely to come up on tomorrow's exam. Do pay attention to these topics and revise them a bit more, and good luck on your exam tomorrow.